Welcome, and now we're going to learn about another triangle congruence theorem, angle side congruence theorem. So two angles in a non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the triangles are congruent. So here we have angle A congruent to angle F, angle C congruent to angle D, and then side BC congruent to side ED. Right, so if we know those things, then triangle ABC is congruent to triangle FED using angle side. So notice that the side is the congruent sides are not between the two congruent angles. So if the two angles and the length of any side are fixed, then the intersection of the other two sides will be fixed too, and the triangles have to be congruent. And we'll take a look at that on the next slide. Right, so be paying attention to what things are in your notes, and I may tell you to add some things. Did it change the page? No, we're waiting. There we go. All right, so we can also prove that triangles are congruent using angle side angle. That was the one we learned about in the last lesson, last podcast. And angle side. Once we know that these parts are congruent in two triangles, all 6 parts of the triangles have to be congruent. Notice that the only difference between these two methods is that angle side angle requires the side to be between the two sides that are congruent on both triangles, and angle side requires the side to not be between one of the two sides. All right, so on the left-hand side, we have angle side triangle. All right, so notice the congruent side is between those two congruent angles, and then the angle side, the side is one of the other sides, not the one between. All right, so angle side is based on the third angle theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. All right, so I don't know if you noticed that angle side is actually angle side triangle congruence theorem rather than postulate. All right, so given two triangles, right, using triangle sum theorem allows us to find the measurement of the third angle in each triangle. Right, so if we take, we add up 65 and 75, and we subtract that from 180, we get 40. And right, so it'll be 40 degrees in both triangles. So angle side angle postulate, right, so that would be we'd have the angle, and right, so we'd have that 40-degree angle congruent to this 40-degree angle, and 75-degree angle congruent to this 75-degree angle, and the side in between those two angles, the included sides, are congruent because they're both 12. Right, that would be angle side angle postulate, showing that triangle BAC is congruent to triangle RPK. All right, but angle side follows from angle side angle. Right, so we know third angle theorem. Let's say we didn't know this one was 65. They didn't tell us. Right, since two angles are congruent, the third angles would have to be congruent too, and then we would know both of those are 65. And if we use one of those angles instead, right, one of these angles here, this one and this one, right, and any one of the other angles with that side, then we'd have angle side. Right, so angle side is a theorem, right, because it's based on angle side angle, right, rather than being proven on its own. Right, it's based on another theorem and third angle theorem. So that's why it's a theorem. All right, so we're going to be figuring out. We've learned 4 triangle congruence postulates. Right? And we're going to be doing some problems with those. First, though, we're going to take a look at angle side and showing why that's true, and why if two angles and any side are fixed, our triangles are fixed. So if two angles and the length of any side are fixed, then the intersection of the other two sides will be fixed too, and the triangles will have to be congruent. Right? So I'll use a line tool here. Right? So this is the side that's fixed. Right? And then the angles are fixed. So this angle here is fixed. Oops, draw it a little off there. And this angle there is fixed. Let me fix that angle. Right? So those angles are fixed. All right? So now all I can do is just continue the rays that make the angle. Let me just fix that a little bit. There we go. All right? So if I continue the angle there, continue those rays, right, you see it connects there. And if I continue this one, you see it's got to just connect there, right? It can't go anywhere else, right? It's got to go there. And I keep getting the same triangle over and over and over again. That's why angle side is enough to prove triangles congruent. Because once I fix those two angles in a side, all I can do is just connect the points. That's it. All right, so if two angles the length of any side are fixed, then the intersection of the other two sides will be fixed too, and the triangles have to be congruent. Okay, and so now we're going to be solving lots of problems, figuring out what kind of congruence postulate is. Right? First, we'll do some that are basically angle side, right? And then we'll mix them all up. Right, so here we have an example, and you might be given a problem, a triangle, and some information. So we're given that angle H is congruent to angle C, and angle HTA is congruent to angle CTA. So the first thing you should do when you are completing a triangle proof is take that information and mark it on your diagram. Right? It's hard to be correct if you don't even know where things are located. Right? So you're apt to make an error unless you mark it on the diagram. Right, so now we look to see, is there anything else we know is congruent? Because that's not enough. We have two pairs of corresponding angles, right? And that's not enough. But we look and we go, hey, look, they both have an AT, right? So both triangles have AT. They share that. So we could mark that one congruent. So by the reflexive property, AT has to be congruent to AT. Now, a congruent statement, right? So now we can match up the congruent triangles. So triangle, we can call the first one CAT, right? So triangle CAT is congruent to triangle. We've got to match up the corresponding parts, right? So C goes with A, right? And so I'd have triangle, excuse me, C goes with H, so I'd have angle, so my triangle would be triangle H, and then A goes with A, and then T goes with T. So I have triangle cat is congruent to triangle hat. Right? And that would be using angle side triangle congruence theorem this time. Okay. Now we might have another congruent statement there, right? Because so long as I match up the corresponding parts, right, I could name this different ways. I chose triangle cat congruent to triangle hat. Let's see what this one says. All right? This one has triangle HTA congruent to triangle CTA. But you can see that H and C are matched, T and T are matched, and A and A are matched. Right? So those are both correct. All right? So if this is in your notes, mark it. Forget which ones are there. And now we're going to do some multiple choice problems. All right, so here we have a diagram, and we have some information. So the first thing we're going to do is mark the information. All right, so HE is congruent to HG. And actually, the very first thing I'm going to do is just fix this. Just a typo there. All right, so HE is congruent to HG. There we go. Angle D is congruent to angle F, and to angle DEH is congruent to angle FGH. All right, so now let's take a look what we have here. All right, so we have, did I mark everything? Yes, I did. All right, so we have two angles that are marked. So let's write that down. So we have two angles. Oops. On this board here. We have two angles, and we have one pair of congruent sides. And actually, I should say two pairs of angles, right? There's two in each triangle. So we have two pairs of congruent angles and one pair of congruent sides. Now, we just got to think, where's the side located? Is it included or not included? All right, so if you look, now so look where your angles are. That side is not between the angles, right? If the side that's between, right, would have to use F and G in one triangle and that would be side D and E in the other triangle. Right? That's the one that's in between the angles, right? Because we can just match up, right? So here we could just match up the angles, right? There are the two vertices of the angles, so D and E, right? That would be the included side, right? So since this is the non-included side, right, it wouldn't be angle, side, angle, but it would be angle, angle, side. Anytime you have two angles, two pairs of angles and a side, the triangles are going to be congruent. You just have to decide if it's angle, side, angle, or angle, angle, side. I wonder if this is it. It doesn't say anything. It was not doing anything. All right, let's look at the next one. Just waiting. And there it is. What type of congruence exists, if any, between the two triangles? So let's write down what we know. We have two pairs of congruent angles. Do we have any pairs of congruent sides? It's really hard to get congruent sides unless you have a shared side. Right? So we have no congruent sides. We have no shared sides. Right? So we have no congruent sides. Well, if you don't have any congruent sides, it's going to be non-congruent, right? You have to have at least one pair of congruent sides, right? And if you have two angles and one pair of congruent sides, then you can prove your triangle is congruent. But no sides, nope. Can't do it, right? We can't prove them congruent. We'll talk about this more. We have just the angles congruent. We'll talk about this very briefly at the very end of this podcast, or near the end. Actually, about 3/4 of the way. All right, so what type of congruence, if any, exists between the two triangles? All right, so we have two pairs of congruent angles. Do we have anything else? All right, so notice they share this side. So we have one pair of congruent sides using the reflexive property. The only thing we have to decide is it between the angles or not. All right, so if you notice, if you follow the side out, look what you see, angle, angle. So this is the included side. And since it's the included side, it's going to be angle, side, angle. Let's see if it says anything on this one. Nope. Some of the times it does. Some of the times it doesn't say anything under the answer sheet. All right, let's try another one. And there it is. All right, what type of congruence, if any, exists between the two triangles? All right, so we've got one pair of angles marked, right? But these angles are also congruent because those are vertical angles, right? And vertical angles are always congruent. All right, so we have two pairs of congruent angles. One was given, one was vertical. And then we have one pair of congruent sides. You just got to look to see where the sides are. Are those sides between the angles? Well, this is between the angles, right? Those sides there. But we don't know those sides are congruent. We know some other sides are congruent. We know W, Q, and RT are congruent. Right? So since it's a non-included side, this would be angle, angle, side. Right? There's another one done. And we're ready for another one. And here comes our page turning right now. All right, what type of congruence, if any, exists between the two triangles? All right, so notice what we have. All right, we have a pair of sides. Two pairs of congruent sides and one pair of congruent angles. Now you got to check, are the angles between the sides? Right, so now if I follow the side down, right, follow the side, so if I follow the side follow the side to the angle. Look where it's located. The angle is between the two sides. Right? So if your angle is between your two sides, this is literally this is the vertex. So if the angle is literally on that vertex that connects those two sides, it is the included angle, and it would have to be the included angle to ensure the triangles were congruent, and we would have side angle side, triangle congruence. Let's see if this one says anything. We're 0 for 3. Right, but so far we've proved all the triangles congruent. If they were congruent, and we had one that wasn't. How about this one? All right, so here we have some information that we're given, right? So we have two pairs of congruent angles, and we have one pair of congruent sides. So now just ask yourself, is the side between the angles? Well, you can see a side is not between the angles, so it's non-included. And if it's the non-included side, it is angle, angle, side. How about this one? No, I should probably get rid of them. I think I've tried. They don't want to go away now. Either that or write something behind it. All right, so let's do another one. And then we'll also be learning about angle, angle, angle. All right, so what type of congruence exists, if any, between the triangles? All right, so we're given that BD bisects angle ABC. So we have some information up there, right, that's already marked. We have angle A is congruent to angle C. If BD bisects angle ABC, right, that means that angle ABD is congruent to angle CBD. And this is because an angle bisector divides an angle into two congruent angles. Right, so that means that this angle is congruent to this angle. Right, do we know anything else is congruent? Right, so we've got two angles. Well, not only do we have that, we also know that BD is congruent to BD, and that's the reflexive property. All right, so now we've got two angles and a side. Side's not between the two angles, so we have angle, angle, side, triangle congruence. How about this one? This one has one. All right, so marking the bisected angle and the common side, which is the reflexive property, you can see angle, angle, side holds. So every so often there's something underneath those things, right? And angle, angle, side is the correct triangle congruence postulate. Right, so always mark your information so you can see, don't make a guess. And do we have another one, or is it angle, angle, angle? Let's see what comes up next. We'll have another one. All right, so actually this is a good one to have. All right, so what do we have? Well, I see three pairs of congruent angles, but no congruent sides. Right? If there's no shared side, you really can't get any congruent sides unless they're given. And there none were given. There's nothing shared. This is not congruent. Right? This would be angle, angle, angle. Nothing behind there. Angle, 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 and that is not a triangle congruence postulate. Right? So we can't prove these triangles are congruent at all. And actually, I'm going to go back to that page before we look at angle, angle, and I'm going to add one thing, what we need, right? So we need, so if you're telling me that two triangles is not enough information to show they're congruent, I'm going to ask you to explain why not. So in this case, this is the why not. We need at least one pair of congruent sides to prove the triangle's congruent. I can't do it with just angles. Right? If we have three pairs of congruent angles, Right? That can't prove triangles congruent. What it can do is prove triangles similar. And we're just waiting for that to come back again. Right? So angle, angle, angle works fine to show that triangles are the same shape, similar, but does not work to show they are the same size, thus congruent. Consider the following example. You can easily draw two equilateral triangles that are the same shape, but are not congruent. They are not the same size. So remember, angle, angle, not a congruence postulate. All right, let's do a couple more. All right, so we're going to identify some congruent triangles. Can the triangles be proved congruent with the information used in the given in the diagram? If so, state the postulate you would use. Now, I'm going to mark anything else we know to be true, and we could mark this. All right, that would be third angle theorem. But all I'm able to get is angles. So there's not enough information to prove the triangle congruent because no sides are known to be congruent. This one might be in your notes. No sides are known to be congruent. Oops. No sides are, actually all I have to do is write sides. Sorry, the rest of it's in the next line. No sides are known to be congruent. Let's see, we can mark one other thing, right? Let's fill in what we can first of all. So the two pairs of angles are congruent, we have that. And by the reflexive property, the shared side is congruent to itself. The triangles are congruent by the angle side triangle congruence theorem. Right, we have two known angles, right, and a side, and the side is not the included side. I think we've got a couple more. I don't think we have any more multiple choice though. I think we have a couple fill-ins. There we go. All right, so can STW and VWT in both diagrams here be proven congruent with the information given in the diagram? If so, state the postulate theorem you would use and identify the parts. All right, so here you have overlapping triangles, right? So separate those overlapping triangles. I'm not going to draw this to size because, well, I don't have enough space, right? But that's not important. This is just a model. It doesn't have to be perfect. We just have to label things correctly. All right, so this would be T, and notice there is a right angle marked there. This is a 60-degree angle there, and that is S, and this would be W. And on the other side, this would be T. This would be W here, and that is a right angle. And then V here is a 60-degree angle. So we've got two angles. Do we have any sides? Well, notice there's a TW in both of those triangles. Right? That TW is right here. Do you see how this triangle, STW, and this triangle, VWT, how they share that side? Right? So we've got angle T is congruent to angle W. That was given. Also given, angle S is congruent to angle V. And it's fine to use just one letter because there's only one angle there. Right? And also given. Right? And then TW is congruent to WT. That's, oops, my T looks funny. That's the reflexive property. And that's enough information. You just mark it there. Right, to prove our triangle is congruent. So here, triangle STW is congruent to triangle VWT. And our postulate would be angle side, triangle, congruence theorem. All right, let's try the next one here. All right, these ones aren't overlapping, so we don't need to draw them separately. All right, so again, we've got angle T is congruent to angle W. And that's given. It's also given that, actually I should probably be specific because there's two angle T's and two angle W's. I mean, there kind of is over here, but we never used it, so. But this time we are. All right, so angle, let's call it angle STW right, is congruent to angle VWT, and angle SWT is congruent to angle VTW. All right, so one's the right angle and one's the other angle, and that is given. And then notice they share this part, right? So WT is congruent to TW. That's the reflexive property. So we can prove the triangle is congruent again. So triangle STW is congruent to triangle, that would be, so VWT. And that would be, this time the side is between those two angles. So this would be angle, side, angle. I'm running out of space here. Let me just, it's a little crowded. I don't know, somehow I've run out of space. I think this is too low. That might give me more, ooh, lots of green dots. All right, so this was triangle STW, congruent to triangle BWT, and this is angle, side, angle, triangle, congruence postulate. Right? And so we were able to prove both pairs of triangles congruent in both of the problems there, but just using different theorems, because different theorems apply based on what we were given and what we could prove to be true, what we knew to be true. And I think I have one more. When we see a blank screen, that's going to be in. All right, so what additional congruence is needed to show that triangle JKL is congruent to triangle NML by the angle side congruence theorem? All right, so here we want it to be angle side. All right, so first of all, let's mark what else we know. All right, so we know that we've got KL. KL is congruent to ML, and that is given. We also know this angle is congruent. So angle KLJ is congruent to angle, let's see, that would be MLN. And those are vertical angles. All right, so we need one more thing for angle side. All right, so we have to make sure the angle is not between the two. Right? So if we choose this angle, these two angles here, notice we would have angle side. Right? So we don't know they're congruent, but that's what was needed. So angle J would have to be congruent. I'm not going to write that they are congruent because we don't know that. But angle J would have to be congruent to angle N to prove the triangle is congruent. Using angle side, triangle congruence theorem. All right, so now in the last three problems here, we're deciding if there's enough information to show the triangle is congruent, and if so, the postulate you would use. All right, so first of all, we know that, I'm going to try this as a little proof, so I can write small. All right, so AB is parallel to CD, right? That's given. I'll just do this. All right, it's right underneath it there because we're going to run out of space. All right, so if that's true, we know that this angle would have to be congruent to this angle, and this angle would have to be congruent to this angle. So angle DAC. So now we're bringing back things from what we learned about with parallel lines. Angle DAC would be congruent to angle BCA. And angle, so now we need the other ones, BAC would be congruent to angle, let's see, BAC and DCA. Right, and that would be alternate interior angles formed by parallel lines. That's one other thing we know has to be congruent, and that's this right here. AC has to be congruent to CA, and that's the reflexive property. And it's getting crowded here. Probably should extend the board, but my extended page is like on my tray there. I can't even see it. I think the screen is a little off and doesn't move up anymore. I don't know why my extended page is below the thing. All right, so here we have our information. Can we prove the triangle is congruent? So if we look, see what we have. We have two angles, the side in between. This would be angle, side, angle, triangle congruence postulate. So this one I think is in your notes. If it is, fill it in. Good thing to do. So we took a lot of space there on that one, but we won't need too much space on this one. Right? We have no sides known congruent and no shared sides. And I'll put and no shared side. All right, so therefore, this is not possible. There's no way to prove triangles congruent if you don't have any sides. All right, so we're done with that one. Now let's move to the last one. All right, so let's see what we got here. We are given, right over here, that angle P is congruent to angle N. We're also given that KL is congruent to ML. Right, so that's given. And then we know these angles have to be congruent. Right, so angle KLP is congruent to angle, so that would be MLN, because they are vertical angles, and that gives us all the information we need. We've got two angles, the sides not between, so this would be angle, angle, side, triangle, congruence theorem. So there we go. We could prove those triangles congruent. So 2 out of 3, and I've heard 2 out of 3 is not bad. I think that's the last one. Let's see if I'm right. And we're just waiting for a page to turn. And once it turns, we can see it's a blank page. So that means that's it. Thanks for watching, and bye for now.